All right, so let's begin. Thank you everyone for making time today for our Crunch and Learn. Kind of a plan words of Munch and Learn. It's given we are crunchy data, and the idea is that people eat. People are having meals all over the world at different times now. It might be dinner time for some of you, in which case, thank you for making time during dinner. It might be your midnight snack. It could be lunch or it could be breakfast. So we're glad that you can join us at this time, and hopefully you're having something very delicious. I myself had a very tasty New York bagel, which by definition is the only kind of bagel that there is. And yes, I'm a humorous New Yorker. But enough about what I ate. Let's talk about our main topic today, which is Crunchy Postgres for Kubernetes 5.0. I'll give a little bit of background as we go through it, but just to give you a little bit of the format of the presentation today. We're going to talk about our latest release of Crunchy Postgres for Kubernetes, which is powered by Pigo, the open source Postgres operator from Crunchy Data. I'm going to talk a little bit about the release, what it does, some of the general architecture and features of it, and then we're going to get into a fairly immersive demo. If you have questions, please ask them in the chat, and at the end, our marketing coordinator extraordinaire, Sarah Whiston, will read them back, and I will do my best to answer them. So without further ado, let's dive into the presentation. So just a little bit about myself. I'm the VP of Platform Engineering at Crunchy Data. I've been at Crunchy for several years. Before that, I was in some various engineering leadership positions in startups. And really what drew me to Crunchy was just my love for Postgres. I came from an application development background, and I actually would always build my applications around Postgres and try to leverage all of its cool features. I mean, including, let's say, full text search, which we put out a blog about that just the other day. That led me to become a Postgres community contributor. I've been active in particularly the governance advocacy aspects, and I sit on the core team. And since coming to Crunchy, I've shifted more from application development towards operations development, and helping to manage our platform-related products, including Crunchy Postgres or Kubernetes. And for those of you who are not familiar with Crunchy Data, Crunchy Data has been around for, I've actually lost track of how many years. I think it's pretty much close to a decade. And what we try to do is we try to make sure that Postgres can be deployed safely, securely, in a fault-tolerant way, in a scalable way, throughout your enterprise or organization. I started with certified open source Postgres distribution. It was the first certified open source Postgres distribution, and then really looking at how can we do this at scale. We've done this through our Kubernetes experience, through virtual machines, with our Ansible experience. We actually also have Crunchy Bridge, which is a fully managed cloud service. And for us, we believe that open source is the enterprise solution, and we're just very large to all the projects we do. And in turn, we like to open source the work that we're working on, including the Postgres operator, which is what powers Crunchy Postgres for Kubernetes. So let's dive into it. What is Crunchy Postgres for Kubernetes 5.0? Well, it really comes from many years of experience having run Postgres on Kubernetes. Crunchy actually started deploying Postgres on very early versions of Kubernetes, very early versions of OpenShift, when containers were not yet the terminology. They were called cartridges. And just going from there, that initially the question was, can you deploy Postgres in a container? And we solved that very early on. And we just continued to build on that. When we released the Postgres operator version 1, there actually was no custom resource definition API in Kubernetes yet. It was the third-party extensions. So building on that and seeing how Kubernetes has evolved, how OpenShift has evolved, how the various distributions, Rancher, GKE, AKS, EKS, and so on and so forth, has allowed us to really tailor this release to what the modern, the modern Kubernetes experience, and really bring the preeminent Kubernetes native Postgres solution. And what do I mean by that? What I mean is declarative Postgres. And we can do the definition off the screen here, but what declarative Postgres is actually something that speaks to me as an application developer. Is I don't necessarily care about the internals of my Postgres database, and it hurts me to say that just being a Postgres contributor, but it's kind of true. It's like I just know I need I need 8 gigs of RAM, and maybe I don't even know if I need that. I just need a database up that has high availability, that has backup set up, that has monitoring, and allows me to troubleshoot my application. And maybe I dive a little bit more into the details. Like I know I need 8 gigs of RAM based upon my data set, but I just want to say here's what I want and let it go. This is not necessarily a novel concept. This comes from, the many years of DevOps. I mean, you can go all the way back to like CF Engine in terms of how you declare your infrastructure. But the difference is that we're applying this to Kubernetes. I mean, you can get this from, something like Crunchy Bridge, where you push a few buttons and boom, you have your database. But we see that, organizations are investing heavily in Kubernetes and, having their application developers, build up their databases in this way. And the idea is that it might not be too difficult to get a Postgres database set up in Kubernetes, but that little development database is eventually going to turn into a production database in some way, shape, or form. And our goal is always to make it as easy as possible to deploy Postgres in production. And with the push to GitOps and declarative, we want to build an operator that gave you a way to make it very easy to get a production Postgres deployment with very little effort, and that could be fully managed in a self-service way by the Postgres operator. So that is really the heart of Country Postgres Kubernetes 5.0. It is a production Postgres made easy by creating a declarative way to do that. Let's drill into like some of those terms, and I call it like the overarching theme of the release. Country Postgres for Kubernetes 5.0 is fully declarative. Everything can be done from YAML. We created example customize and Helm charts and the OLM if you deploy from Operator Hub. And basically, we make it as easy as you want to get started. Just with a few examples or just a couple commands. Actually, just one command, you can have a Postgres cluster up and running. But we allow you to be able to fully customize it as well. We really took GitOps to heart. Kelsey Hightower's stop scripting and start shipping. We want to make it as easy as possible to get applications up and running, but be able to do it in the GitOps way, where you can move forward, roll back, and the operator is able to put the cluster in the state that you desire for it. Additionally, the operator is going to do its best to make sure that if there's an issue, it's able to remedy it. But some of this, we'll look further into what I mean by that in a few slides, but there's certain things that the Postgres clusters can do to heal themselves, and there's certain things where an operator can come in and say like, oh, I see, this Kubernetes aspect is, out of line. Let me go and fix it. It's easy to upgrade. We've made it much easier to apply updates in a non-disruptive way. For instance, there's going to be a Postgres update release coming out in about 2 weeks. You probably want to take it. There's going to be some nice bug fixes in it, but you want to do it in a way that's non-disruptive. Country Postgres Kubernetes lets you just apply that single update and do it in a rolling fashion so that there's minimal to zero disruption to your Postgres clusters. And as I said, the idea is that this is production grade. We do a lot of things. We've been running Postgres and Kubernetes for well over 5 years now. Actually, it's probably closing in on 7 years, and we've seen a lot of what happens with Postgres in production in the Kubernetes environments, and we try to encode all of those lessons into the operator. So with that, let's drill into a few more of these points to see what we've done in Country Postgres or Kubernetes, and then we'll go into a demo. So fully declarative Postgres. We try to make it as simple as you say that you want high availability, you say you want disaster recovery, you say you want monitoring, you want things to be secure. You put in your your YAML checklist, send it off to Kubernetes. Pigo, the operator, sees it and says, okay, let me build out that cluster. And it's going to automatically configure it for your production requirements. There are a few things that we were very adamant about in this release. For one, we give you TLS out of the box. And this is, we see this has become a big requirement in Kubernetes world, and we just want to make it as easy as possible to do that. If you don't want to use a TLS, you can bring your own. We actually have a blog post coming out to show how to do that with a very popular TLS library. And we also want to make it secure for your applications to connect. We're going to see how if and some of it does involve making sure you're designing your applications in the 12-factor way. But if you do so, you can securely drop in the credentials in a way where the application developer does not need to know anything about your credentials for connecting to the database. They can just drop it in and their application will just work. Big thing is also auto management and healing. And this is something that we had in the previous version of Country Postgres for Kubernetes, but we've taken it to a different level. There's certain aspects where you actually don't want the operator involved. The operator helps configure things, but the Postgres clusters can manage it amongst themselves. Some of it, high availability is one thing. We use a distributed consensus-based high availability system to make sure your Postgres instances stay up and running. But there's other, there's things that go beyond just Postgres when you're managing things in a Kubernetes environment. For example, let's take your connection pooler. Connection pooler might be governed by a Kubernetes deployment. Well, let's say, something happens, someone comes in and accidentally deletes your connection pooler deployment. Well, if you don't have any logic in place, for that, your connection pooler is going to be down, and that's going to cause downtime. Country Postgres for Kubernetes 5, it's going to detect that that connection pooler is gone, and very quickly it's going to recreate it. So that way, there is hopefully, no noticeable disruption to your application. This allows, your cluster to heal and be managed, and be able to have continuous operations, and not having to come in and wake up at 3 in the morning to intervene. This is the Country Postgres for Kubernetes 5 advantage, is being able to automatically manage your clusters and keep things online with minimal intervention on your part. As I mentioned, this is built for GitOps. One thing we did a lot, while we were testing Country Postgres to Kubernetes 5 was, running it through popular GitOps tools like Argo, or actually Argo CD, I should say, and making sure that it would work, as we scaled up, scaled down, went forward, went back. But the idea is that, even though we build this as, production-ready Postgres, it really can work at any stage of your pipeline. And I think that is what truly production-ready Postgres is, because, you might start developing, on a development database, and you scale it up for QA to, do some additional things. For staging, you want to create an environment that mirrors production, then ultimately you can roll it into production. The idea is that with Country Postgres for Kubernetes 5, it's ready for continuous delivery of your applications, and and to work with all of your different modern GitOps tools. As I said, updating without interruption is very important to us. I think we're familiar that the Kubernetes ecosystem moves fast, which is great because it's amazing to see all the new features that make it into Kubernetes. It definitely keeps all of us on our toes. But as such, this means that there's a lot of different updates that come in. Arguably, people might say, Postgres moves fast. Once a quarter, there's a series of bug fix releases, and given that the database is often the critical linchpin of your applications, you want to make sure you can apply those bug fixes, or if there are any security fixes, without any interruptions. Totally understand this. In my previous life, sometimes I would hesitate to apply a Postgres update because I was worried about the disruption to the application, or I would stay up till like 3:30 in the morning to apply the update so there's minimal disruption. I don't wish 3:30 in the morning upon anyone, though we currently have a newborn, so I'm quite often up at 3:30 in the morning anyway. That said, my main focus is not to apply patches at that time. It's to try to get the newborn back to sleep. That all said, let's be able to apply updates, in the middle of the day in a way where the application is not disrupted. And should something go wrong, you're much fresher and you're able, to be able to handle it. And that's the idea with the implementation of Country Postgres to Kubernetes, is that when we detect that an update is going to be disruptive, we apply it in a way that is going to be minimally or have zero disruption to your application. So we will see this extensively in the demo. And finally, in terms of drilling into the high level stuff, we've maintained infrastructure agnosticism. This is across the board. We get this in many different ways. One, Country Postgres or Kubernetes, works across all the different flavors of Kubernetes. It works on any cloud. We can store backups in a whole variety of ways. In addition to Kubernetes local storage or something like NFS, we can store backups in S3, Azure Blob Storage, and GCS, Google Cloud Storage. And you can actually store backups in multiple locations at once. That's a big advantage. So, it's very, people like to, for instance, keep their backups locally, as well as, keep them in a blob service like S3. We actually allow you to store backups in up to 4 different locations if you really want to do that. Additionally, we support multi-Kubernetes deployments. So you can have an active Postgres cluster in one data center and a standby Postgres cluster in another data center that's being able to receive the updates in real time. And it'll really allow you to extend your disaster recovery solution from there. If you read some of my blogs, you may even be able to figure out how to have 2 active clusters connected to each other, but that is a very long topic for another day. So a couple more slides, and then we're going to demo all this. So we really try to bring all of those enterprise-grade features to the Postgres experience on Kubernetes. And the first one everyone looks at is high availability. am I able to keep my Postgres clusters up and running through whatever activities may be going on? A node goes down, there's a network split. And the answer is yes. We've been running this solution for a long time, and we have a consensus-based high availability solution for basically building out these always-on architectures. We'll see some of this in action today. Disaster recovery, and I like to lump backups into here as well, but a lot of people say, a lot of people tend to focus on high availability for Kubernetes, and I understand it. That's one of the billings of it. You see that built into a lot of the native Kubernetes objects. I'm more concerned about backups because, as I always like to say, you're only as good as your last backup, and the reason is things can happen in storage, and you don't, for a lot of different reasons, and you always want to make sure that you have a backup available. So we spend a lot of time focused on our backup solution. The backup solution, it was designed to deal with, very large databases, though, it does work with small databases as well. Actually works fairly well with small databases. And as I mentioned before, it's available in all sorts of different flavors of storage. And as I also said that, for the disaster recovery aspect, you can span, multiple Kubernetes clusters, or you can run multi-zonal clusters as well. It's really up to you. And as I always say when I give a talk like this, if there's one takeaway, high availability is very important. And don't get me wrong, but make sure your backup solution is solid. That's one of those things that it comes back in spades when you truly need it. As someone who has had to do point-in-time recoveries, monitoring. We've built out a full-fledged monitoring solution that gives you Kubernetes-specific Postgres insights, and has built-in alerting and helps you spot problems before they occur. This has actually become a very popular solution, and the idea is that we make it as turnkey as possible. And again, much like all the things that we offer in Country Postgres for Kubernetes, we offer integration into your already existing monitoring platforms. Security. Crunchy Data was founded on the premise of making sure Postgres could be securely run in enterprise organizations, and we carry that forward into Crunchy Postgres to Kubernetes. We make sure all of our containers are unprivileged, they're locked down, and as I mentioned, we enable TLS by default. We also provide secure credential management. Performance and convenience I kind of like to tie in together. You can certainly scale your database to meet your workloads, and we make it very easy to customize and tweak the Postgres knobs to make sure that you're able to match your Postgres database to your workload. We make it, as I say, make it fairly easy to customize. And we make it possible to do things that application developers love, like cloning data. When I was managing databases for a team at one of my previous companies, that was one of the most popular requests, bug in production. I can't reproduce it. Can you give me a clone of the production database? Sure, here's a clone of it. Here's some of the data sanitized, here you go. And making it as simple as possible to do that. With Country Postgres or Kubernetes, this is a one-line command. We include connection pooling and some other niceties to make it easier to maintain applications. So, I've probably been talking a big game for about 20 minutes now, and this is at the point of the presentation where a lot of people say, "Well, this all sounds great. Can you show me if it works?" So let's go and see if I can pull off this live demo. So I'm gonna take a quick drink of water, and as I do that, I'm gonna get the demo set up. So here's my screen. The terminal, hopefully the terminal is big enough. Sarah, if the terminal is not big enough, please shoot me a quick note. And what we're going to do is we're going to deploy an application called Keycloak today. So first, I just want to walk through the manifest for doing so. Here is my here's my screen. Let me actually blow up this text a little bit. There we go. So here's a manifest for deploying a Postgres cluster, and it should look fairly straightforward. I'm pulling in my Postgres image. I'm saying I might want two replicas. I'm going to set some anti-affinity rules so that way they can be deployed in a high availability manner. I'm actually going to turn on monitoring with it, and I'm getting my backup set up. You can see I have a few things commented out. That's just to make it easier for me to do the demo later on. But if you ignore the comments, you can see it's fairly easy to get this set up. Now let's look at the Keycloak manifest. So Keycloak, if you're unfamiliar, Keycloak is an identity management authentication application, and it's great. We actually use that Crunchy Data for some of our stuff. It's great. It's very configurable, and even better, it's backed by Postgres. So in order to connect to the Postgres database, I'm able to actually, knowing that I'm going to be creating a secret, I'm able to take that secret and map those credentials directly into a key cloak. And what's great about this is what I mentioned is that as an application developer, I don't need to know anything about the credentials. As long as my application is following proper 12-factor practices, I can just tie it in. And this is great in terms of creating a separation of boundaries between development and production. So let's get that kicked off. Let me go to my script, and we are going to deploy this. There we go. I'm actually at the same time going to deploy our monitoring dashboards, just to make sure those get all brought up. And it's also to populate some data into it for later on. So we're going to see, if we go and see what's going on, we're going to see that everything's being brought up by the operator. I probably should have shown that I'd already deployed the operator, but you can give me the benefit of the doubt there. So everything's coming up. While we're doing that, let's look at one of the niceties. Is that our custom resource definition works completely with kubectl explain. You can use it to fully introspect the custom resource definition and figure out how you want to configure everything. You can also go to our documentation, which puts this in great detail, and also includes a tutorial for how to do actually a lot of things that we're doing today. So let's see the state of our cluster. See if everything's up and running. Yep, it looks like everything's up and running. Keycloak might take a moment to connect. But if it is up and running, what I'm going to do is I'm going to create a port forward so we can access. Oops, I don't want to do it in this terminal. Let's create a port forward. Let's see if we can access it. Yep, there we go. So Keycloak is up and running. Let me try logging in. Great, I'm in. So it looks like everything's up and running. So how do you know this is not a parlor trick? Let me make a modification to the display name of Keycloak. We're very excited we're using Keycloak. Great. And now let's see if it persisted to the database. So I'm going to do a little trick to connect to the database. I'm just going to exec in directly and run a command. And success, we see that we modify the value. Great. So everything's working as expected. We brought up effectively a production Postgres database, with very little work. In fact, really I could have just copy and pasted the example directly from our Postgres operator examples repository. Now, let's start creating some disaster. The key thing about connecting to the database is we're connecting through a service. In particular, to the primary database, we're connecting through this primary service. That's great, but what would happen if I were to delete that primary service? Well, nothing would work, right? Because I delete the service, I'm no longer able to connect. That's pretty bad. But if I look, the service is back because what happened is the Pigo detected that the service was deleted and basically said, hey, no, this is bad. This is not what you requested. You requested for a fully working Postgres cluster with a primary service. And I'm just going to automatically recreate this. So it seems like there's no disruption. So let's see what happens to our connection. Now, some of this might be, depending on your application, there might be some retry logic or not in it. It seems like, we came up, fairly quickly. And let's see if, we're still writing to the database. So it seems like this saved. Now let's go back and see if it persisted. Yep, it persisted. So here's an example of auto healing. So if some chaos happens within your Kubernetes environment, the operator is able to heal fairly quickly. Now let's scale up. This is something that's fairly popular to do. It's like maybe I don't want 2 replicas, I want 3 replicas. I really want to ensure that this cluster is highly available. Okay, so let's edit our manifest. Let's make it let's move it to 3 replicas, and then let's apply the change. All right, so I'm going to, while we're applying the change, I'm going to, let's watch and see it come up. So we can see that the operator is already trying to create the new instance, and it brought it up fairly quickly. And now what's happening is that the instance is becoming synchronized with the other Postgres instances, which might take a moment. And here we go. We can see that it's detected that it's a replica. It's reading in all the changes. And boom, like it's already set up. So this is great. We have now a 3 Postgres cluster, highly available, database set, and everything looks good. Well, Okay, so far so good. So let's apply a rolling update. There's certain actions that naturally cause a rolling update. If Postgres 13.4 happened to be out and I want to update it, well, changing out an image on a Kubernetes object would certainly terminate a pod. Another thing is increasing the resources on the pod. So let's do that, as that's something we can do right now since 13.4 is not out yet. So I make that change. Let's save, and let's see what happens with our rolling update. So the operator is going to detect the change, and what it's going to do is it's first going to go through each of the replicas and apply the change to it. So it's going to wait to make sure that each Postgres instance comes back before it moves on to the next one. So that way the updates can be applied safely to it. After it does the replicas, what it's going to do is then it's going to do a controlled switch over to the best replica candidate, and it's going to turn that into the new primary. So that's coming up. Let's see if this replica that we had actually got the changes that we requested. And if I'm able to read through all these things, I should be able to show, here we go. Here's our memory request. It is applied. So it's going to be rolling through and doing that to all of the other ones. So we can see that the second replica just got the changes applied to it. Everything is good. And we see that there was a controlled switchover that we applied the changes to we promoted the other replica, and we're applying the changes to the excuse me, to the old primary, which is eventually going to come up as a new and healthy replica. So there you go. We're able to apply all these changes with minimal disruption. So let's just watch this come up, and we're going to now go back to Keycloak and see what's happened. So as mentioned, depending on your application retry logic, it might take a couple times to retry. In this case, things were immediately there. Let's see if our change, if we're able to write to the database. Yep, it seems like it's still writable. Let's see if that we're still able to persist the changes to the database. And I believe the answer is yes. So there you go. We were able to route the right traffic to the new primary, and there was minimal, in this case, zero disruption in that process. So let's get a little fancier. We talked a little bit about backups, and currently we have our backups going to a local repository. Let's get some backups also going to an S3 bucket. So I configured a few things to be able to help with this. So this is basically telling me that I set up some my secure S3 credentials in a Kubernetes secret, and I'm defining some information in terms of where I want to store my my credentials in S3. I'm going to enable a second repository, which again has information for how to connect to it. And I do need to add one thing into my customization, in terms of how to reference the secret. So we have all that in place. Let's apply the changes. And let's see what's happening. All right, so it's actually gonna take us a couple minutes to get things set up because I'm running the demo on my local cluster. It's gonna take a little bit of time to get information out to S3. But we can see that if we were to run a pg backwards info command, okay, so it's not ready yet because you actually can see there's a rolling update going on to make sure the new changes are applied to the configuration of S3 is applied to each Postgres instance, and that's fine. This is to make sure that we're able to push the write ahead logs, which are an essential ingredient for point-in-time recovery, out to the entire cluster. As I mentioned, as we go through this, we want to make sure that you're able to modify where you're storing your backups during the lifetime of a cluster, because this is something that does naturally happen. For example, this is actually a situation I ran into, in one of my previous organizations where we were taking backups to a local disk, a disk that was within our network, but we were quickly filling up with traffic there. So what I did is that I moved the backups to S3, which was actually a fairly arduous process because again there's the whole downtime equation. So what I was able to do was what I like about this solution though is that this makes it easy, that the operator is handling that process for you. So let's see where we are at in the process. Okay, we're still we're still booting up. So while we're doing that, I'll actually go into the manifest to make a couple more changes. First, I want to talk a little bit about a few things. First, it's the ability to create scheduled backups. Scheduled backups are actually the best way to manage your backups because you don't need to think about it. You just turn on the schedule and it will continuously take backups. We're gonna turn that on in a bit. I might also need to take manual backups as well from time to time. And you might say, Jonathan, well, a manual backup, that sounds like an imperative action. That's not a declarative action. And you're right. But there are certain things that are imperative actions. So what we're doing is, we're basically enabling, what we do is we basically allow you to define how you want that backup taken, which is the declarative piece of it. And then we let you apply an annotation, which allows you to, in a declarative way, take an imperative action. So let's check in on the state of our cluster. Okay, it seems like it's almost up now. As I mentioned, it takes a moment to get the S3 going. I think I'm going to give that a few more moments, and I'm going to skip ahead into the demo to monitoring. So we talked about monitoring before, and monitoring is it's the best way to anticipate problems in your cluster before they happen. For our standard monitoring stack, we use Prometheus and Grafana, which of course are very popular open source tools. So let's log in. Skip changing my password, and let's go to the dashboard. So we provide a few a few predefined dashboards. For instance, we're able to monitor every Postgres cluster you have. So this is a high availability cluster, and everything is healthy, which is good. So let's drill into our details. You can see, we just started, we've been taking statistics for about, ever since I deployed the cluster, and this is a fairly low traffic cluster right now. I'm not running any benchmarks or anything about it, but the idea is that we provide some fairly fairly easy to interpret charts, as well as the key metrics that you need in order to diagnose issues within your database. We can see the current state of it. We can see there are things like replication lag. We can see how much activity is on the database. This might help you determine things like, do I need to resize my database? What are the health of my backups, and so on and so forth. Any pod details yet, but some of that could be just the delay in terms of gathering everything from Prometheus and Grafana. All right, so let's check on the current status of our database. Okay, to see if we can get some info. Nope. All right, of course it's a live demo, so I'm sure I messed up something in the configuration during it. So let's try and take a manual backup, and I'm going to pivot, and I'm going to take a manual backup with hang on one second. I'm going to take a manual backup with with our original repo. So I'm going to unwind this real quick. Of course, you will not believe me if I said that this was all working just before the demo, but this is the live demo. All right, so we'll go back to just one repository. Actually, I'm gonna do two things. I'm gonna show you how to take a manual backup with it. One second. As I mentioned, the way you take a manual backup is that you apply an annotation. We recommend, we provide script for it in the tutorial. We recommend, basically assigning a date time to it. And then, we check the pods, see if the manual backup is taking up. And of course, I messed up my command. That's okay. This is why we do live demos. All right, so while I'm troubleshooting that, let's also add a schedule backup and see what happens. All right, so now we have a scheduled backup, and those are going to be stored in Kubernetes cron jobs. Should they be applied? And essentially, those run at every so often. So while that's going on, let's connect up a connection pooler. So the connection pooler we use is a open source tool called PG Bouncer, and and our plan is that we're going to deploy this connection pooler in a highly available way as well, since we want to make sure it's spread out. Should a node go down, and you still need to maintain connections. So let's apply these changes, and we'll see that PG Bouncer is coming up. Or not. Of course. Here we go. So PG Bounce is coming up. Things are reconciling now. Okay. So while that's happening, let's I'm going to show you that PG Bouncer is actually deployed to different nodes. Thanks to our anti-affinity rules. And let's also change up. Let's just change up our connection to connect to PG Bouncer. So first, actually, I'm going to introspect our secret. To show you that we've added the secure credentials for connecting the PG Bouncer to the secret. This makes it a lot easier to be able to connect directly to the database. And again, it's you don't need to reveal necessarily any of the information to your end user. They just need to know how to configure the secret. So that's in. We apply the changes. And we're going to have to wait for the Keycloak to roll out those changes. And so we modify the template, but that'll take a moment. Meanwhile, while we do that, let's see if we can do some live troubleshooting. Why did I fail at making the backups? Okay, so there's another backup being taken. Okay, so that's perfectly normal. Maybe I actually was able to successfully get that S3 backup working, and I had just lost my patience. I don't know, we're just doing a full backup right now. Okay, well that'll be fairly quick, and then the incremental backups will work. Cool, fun running distributed systems. All right, so it looks like Keycloak is back up and running now. So let's go back and look at Keycloak. Well, first, in order to get Keycloak to work, I need to reset the port forward. And there it is. I'm connected, and it looks like my data. Let me make a change. So now we're connected through PG Bouncer. So we're going through our connection pooler, and sure enough, we're able to get everything working, and the changes persist. So there you have it. It's sort of a day in the life as a Postgres operator administrator. And perhaps in true live demo fashion, I managed to screw something up. But I think the takeaway is truly how easy it is to actually make these changes and be able to scale up and add things to your cluster and modify it. In fact, I did something very GitOps. I messed something up. I was able to roll back, and the operator was able to reset and heal. So let's see if our backup is backup's still being taken. But when that finishes, then the incremental backup will be able to run. Let's check on our monitoring one more time to see if there's any interesting stats we can glean from it. And after that, we will go back to the slides. There you go. So we can see that we do have some active connections. We have some activity going on in the database. We did successfully take a backup over 11 minutes ago. We can see overall the health of our of our typical Kubernetes type metrics. We now have our pod details available. As mentioned, there's a little bit of a initial lag to get them in, but they're all there. And we can see if there's any alerts. Actually, there we go. There are a couple of alerts going on, warning me about disk size. Actually, I'm not surprised that I might have some disk size issues. I've actually been running this cluster for a while. Let's actually now curious about that. Yeah, here we go. I'm at 80%. There you go. I'm glad I was able to trigger an issue live. I wish I could say that was planned, but you can see that here monitoring is helping me to anticipate a problem before it occurs. So now I know at the end of this demo, when our time altogether is finished, I will go in and I will go free up some disk. All right, so let's finish up the presentation and open up the floor to questions. So one thing we like to say about Crunchy Postgres for Kubernetes is that its battery is included. It contains all the things you need to run anywhere from development Postgres cluster to production grade cluster. Includes Pigo, the open source Postgres operator that we've developed. We support Crunchy Postgres 10 through 13. Our older version supports 9.6. We try to stay in line with the community, but with 9.6 being deprecated by the community in the fall, we started with Postgres version 10. This also allows us to use the Scram, which is the modern password mechanism in Postgres, and a topic that I'm heavily obsessed on and can easily talk an hour about. We include many popular extensions, PostGIS, popular geospatial library, Timescale DB, pgpartman, both very popular for time series data, and so on and so forth. I mean, you can read the full list. We use some very popular and well-supported open source libraries. And we have the container images for Crunchy Postgres for Kubernetes 5 available in the EL8 flavors. As mentioned, TLS is included by default. You can bring your own TLS infrastructure as well, and you can tie it into your favorite TLS management utility. And as I've mentioned, backups be stored in multiple places, and if I configured my S3 credentials correctly, we will see the backups being stored in Amazon S3. If you're a current Crunchy Postgres or Kubernetes user, this includes all the features that you know and love. I won't read every single one of them out, but the good news is that you can run version 5 and version 4 in the same environment, which can help you to transition to running Crunchy Postgres for Kubernetes version 5. Yeah, so a lot of this is very familiar if you've been using Crunchy Postgres or Kubernetes before. Overall, we just moved it to a declarative workflow. There's certainly places you can find out more about it. You can visit the website, to read the full product overview. Please check out, our, like I said, everything is open source. Please feel free to check out the repository, check out the code. We've put together, a bunch of examples for how to, run the Postgres operator in, various ways. Please, certainly feel free to check those out and play around with it. And of course, please feel free to contribute. I think that is the beauty of open source is that, we're certainly open to collaboration and doing everything we can to continue to improve the Postgres experience on Kubernetes. And with that, I know we've now spent about 45 minutes of your crunching time together. So I will thank you for staying and listening, and I'm happy to answer questions.
So Jonathan, I can help read out some questions here.
Sure.
So the first question we have is from Tamer. Please forgive me if I'm pronouncing anyone's name incorrectly. His question is it possible to define multiple databases, users, extensions when initializing Postgres clusters declaratively?
Yes, and that's coming out in the 5.01 release, which will be in within the next couple of weeks.
Okay. Next question is from Michael. What happens to in-flight transactions during rolling updates when the primary is updated? For backups, I see full and incremental. What about differentials? So
the last thing is first, you can define differentials as well. If you want me to prove it, we can go to kubectl explain spec backups backrest dot. I forget. I think it's in repos dot schedules. Here you go. Differential. So in terms of in-flight transactions, what we're looking to do is we're evaluating how to tie this into PG Bouncer in a safe way. PG Bouncer has the ability to pause in-flight transactions while you're going through, any type of disruption. But the key aspect of that is to make sure we can resume those in-flight transactions and make sure you're not in a state where, we actually give you downtime or degraded performance. So, presently, if you have an in-flight transaction and there's a disruption, you may lose that transaction. But what I always do on the application development side is I made sure I had appropriate retry logic in the event of that. there's like a little bit of give and take. Like we are trying to make it as matchable as possible to be able to do that. But you should still try to code the applications in ways that are safe to make sure you're able to avoid situations, particularly if you're sensitive to that. Additionally, if you are very transaction sensitive, you can run with synchronous replication on, so you can guarantee that your transaction has at least been replayed and committed to at least one other replica.
Okay. We have a question from Solomon. Is customize/Helm replacing the Postgres operator, which 4.7 uses?
I'm sorry, I don't understand the question. Is this referring to the Pigo command line tool, or is this or am I misinterpreting?
Yes, the Pigo client.
Yeah, so we're evaluating what we want to do with our command line tool at this time. Of course, we'd be happy to listen to various use cases and where the command line tool is useful, and we can evaluate what we can do with that in a version 5 world. So currently we are supporting manifest via customize or kuctl, Helm, and OLM, which actually OLM we can interface through OpenShift directly.
All right, another question from Brett. Will other features from Pigo 4x be available in 5x as well? For example, PG policies, user management, PG admin.
Yeah, so we are, we're looking to bring in the ones that, we're certainly open to ideas in terms of the ones that you'd like to see in, version 5. As mentioned, user management is going to be in the 5.01 release. We're doing some work to make it easier to do policy management, but I'd love to hear more in terms of, what you use policy management for specifically. We're also looking at bringing in PG admin for as well.
Another question from Solomon, will we be getting more fleshed out 5.0 charts/templates?
Yes, and certainly if you have ideas for them, please open up an issue and we can look into what those are. I do strongly suggest going through the tutorial as well, as the tutorial covers ways to further expand upon the charts that are in the examples repository.
All right, last couple questions here. One from Thomas. Once PG 14 will be available in GA, how many times do you expect to get PGO compliant with it?
I'm not sure I understand the question.
Yeah, Thomas, if you have any clarification there, feel free to throw it in the chat and we can try to answer your question. The last one that we have right now is from Dennis. The documentation mentions minor version upgrades, but not major ones. Can these be performed via PGO as well?
Yeah, we will be adding major version upgrades to the next release. Again, much like given the sensitivity of major version upgrades, we're evaluating the different ways to do it in a way that's as safe as possible. Particularly in a GitOps world, but we're anticipating that will be in the next release, and we're timing that for around on or around when PG 14 is available. Of course, like everything in software, we're trying to make sure that we're erring on the side, particularly around a major upgrade, to make sure we can do it safely and making it available. We're confident in that.
Okay, we did have a few more come in. Would you happen to know if Crunchy Postgres and OpenShift can be accessed by external application via HTTP or HTTPS throughout HA proxy ingress?
Yeah, so there's many different ways that people have set up external routing to the Postgres operator. This is one of the, or I guess Postgres operator managed databases. We don't explicitly provide management for ingresses, but we certainly have people who have created their own ingresses that go to databases on that are managed by the operator. So the short answer is that I'm not sure exactly what your ingress policy looks like there, but it's certainly supportable. Like we just actually had a support ticket the other day come in where we had to answer a similar question.
Follow up to that question, is there any link that shows as an example?
There's no link on the Crunchy documentation for how to set up an ingress, but I'm going to make a note of it to see if that's something we want to build out an example for.
Will you need to adapt PGO to work with Postgres 14?
The short answer is no.
All righty. I think we have a couple more that just came in. How to disable TLS.
Yep, so currently we're not letting you disable TLS. However, in an upcoming release, we'll let you set an HBA role if you wish to just have a host-only route to it, route to your database. That actually, I believe that is targeted for the 5.0 release.
Here's another question. Is it possible to add extensions?
Yes. Yes. So there's a few ways you can add extensions. We have extensions that are pre-baked in, but they're not necessarily enabled. You can create them, using the create extension command. You can also add what you need to the shared preloaded libraries, which is available in the dynamic configuration section of the operator. If there's an extension that is not in the container that you're interested in, please let us know so we can take a look at it.
Great. And I think the only one we haven't answered thus far is from Brett. He asks, can you provide detail on what the development process looks like for the Crunchy team? For example, adding a feature or bug fix to the operator.
Yeah, that's a very good question. So we actually provide a contribution guide within the repository. Typically, it's a good idea to open up an issue and follow the template that we've provided, which provides extensive detail in terms of what of the information we need in order to be able to do this properly. So for instance, we have a well-defined bug template, we have a defined feature template, and that helps us to better understand the use case. From there, we can certainly collaborate on the patch. We have some people who throw up some patches and they get reviewed. We go back and forth, provide feedback on it. And we try to encourage that you follow the contribution guidelines. We do, of course, as you write features, we encourage you to also include the unit test in them as well. This provides, some, let's call that some quality assurance to make sure that, everything is working. So I have time for one more question, if there are any questions left.
I believe we've answered all of those that have been typed up thus far, but if anybody has another question, feel free to throw it out there. Will PD Badger be supported declaratively?
Yep, we are. We have that in our roadmap, and we're evaluating the best way to do that.
Awesome.
All right. Well, thank you everyone for coming today. I hope this was informative. We certainly encourage you to try out PGO and try out Crunchy Postgres for Kubernetes. Provide feedback. These are some great questions. You certainly have given me some follow-up work to do. And thank you again for your time today. And we hope you enjoyed this Crunch and Learn and had something tasty while we explored how to run Postgres on Kubernetes. Thank you so much.
Thanks, Jonathan, and thank you everyone for joining.
All right, take care.